So this right here is the vertex form of a quadratic. So these letters represent something super great, and I'm just going to use my handy dandy highlighters to help you out. So A. What does A represent? Well, A represents the width of the graph. Either we're stretching it or compressing it, and it also tells us the direction it opens, so either up or down. So if the absolute value of A, okay, the coefficient that's out here, so if you take into consideration just the A part, not the sign on it, the negative or the positive, just keeping it as a positive, the graph will be stretched or more narrow. If the absolute value of A, or just the numbery bit, the positive numbery bit of A, is between 0 and 1, the graph will be compressed or wider. So that means if a value of like 0.25 is A, or if we have a value of 1/2 as our A, that means it's going to be compressed or wider. And if A is less than 0, then the graph will be reflected in the x-axis, which means that it opens down. P represents the horizontal shift of the graph. Now here's the tricky bit. Because the P is stated as it is, the positive P, if P is positive, the graph will shift right. So that means we have something that looks like x minus P. Now it feels a little counterintuitive because the P is positive, but it's a subtraction, so it looks like the P is negative. But if the P is negative, meaning if we have an x minus negative P, okay, so if we have actually something that results in x plus P, the graph will shift left. Now with the horizontal, a lot of people like to make a note of it. It's always opposite of what you think. So kind of like when we're solving for our zeros, if I would, just going off to the side here, if I were to have something like x plus 2, x minus 1 equals 0, we know that x equals negative 2 and positive 1, because when we set both of these factors equal to 0, the signs switch when we solve for x. The same is with the horizontal shifts on the graph. Q is a little bit more straightforward. It represents the vertical shift of the graph. So if P is positive, the graph will shift up, and if P is negative, the graph will shift down. Together, P, Q describes the position of the vertex, and this is why we state P the way we do, because minus P and then the P, the number that's here, is our x coordinate of our vertex. So this is our x coordinate of our vertex, and this is our y coordinate of the vertex. So let's just take a few moments. What I would encourage you guys to do is to pause it and to try to graph these on your own and try to answer these questions on your own, and use my notes afterwards as kind of just like a checklist. And so if you wanted to, you could pause it, kind of go until the end, like pause it and then do the work, and then scroll until I have all of these values completed. And if you have them all perfect, that means you understand, and you don't have to watch the whole thing. However, if you don't quite get something right, then go back to the point where I explained that specific aspect of the quadratic, and then you can hear full explanation. Okay? Deal. So let's just do A. This is the parent graph, or I like to call it the mother function. So let's just graph this. If I were to give this as 1 and 1, Remember, if I plug in my x values, that's what gives me my y value. So if I plug in 0 for my x, I get 0 for my y. If I plug in 1 for my x, I get 1 for my y. If I plug in positive 2 for my x, I get 4 as my y. So that's why we're plotting here. And I think that that's actually all I can do on this graph. Now if we plug in negative 1 for my x, I get positive 1 in my y. If I put in negative 2 for my x, I get negative 2 squared is positive 4. So I get something that looks like that. So I'm going to connect here, make it look nice and round at the bottom. So my domain, always going to be x is an element of the reals. Now these are a little bit shifted down, but this goes with domain. The range is y is greater than or equal to 0. And you can also put in for good measure y is also an element of the reals. It means that it belongs to the set of all real numbers. The axis of symmetry we can see right here is x equals 0. It's really important that you state that as an equation. The vertex here is going to be 0, 0. The maximum or minimum point is going to be 0. Okay, that's a y coordinate. The x-intercept is going to be 0. The y-intercept is going to be 0, and we are good. This is what we base all of our graphing on. This mother function. Y equals x squared plus 1. So it means that there's nothing happening to the stretch or compression factor here. I'm just taking my parent function and I'm simply moving it up 1. Now I know that it's moving up 1 instead of to the left 1, because it would be to the left 1 if I would say y equals x plus 1 squared. Okay, but this plus 1 is all off on its own. This is actually going to be my q. So I'm going to graph it the exact same way, only move it up 1. So instead of at 0, 0, I'm at 0, 1. And now I know that I go from here and I go over 1, up 1, over 1, up 1. Just like with my parent function, I would go over 1, up 1. There's no stretch factor, so we can do that. And now I go to the vertex again and I go over 2, up 1, 2, 3, 4. And I do the same thing over here. Just like I would go to my mother function here and go 1, 2, 1, 2, 3, 4. Now what I'm going to do is I'm going to make a nice curve to that, make a nice curve to that. Great. Now I can analyze it. So the domain here, as always, is x is an element of the reals. Y is going to be greater than or equal to 1. And y can also be an element of the reals. The axis of symmetry is simply x equals 0. The vertex right here is going to be at 0, 1. The minimum, okay, the minimum is going to be at y equals 1. The x-intercepts, there are none. Don't say 0, because if you say 0, it means that it's at 0, 0. Okay, I should probably stipulate here that this is x and this is y. But if you say none, it means that it doesn't touch the x-axis. So just as an aside here, oh, I should put my scale in. Just as an aside here, the discriminant for this one right here, it would be negative, because never will you have any solutions for this equation. You never have for the equation that y equals 0. The y-intercept is going to be y equals 1. You will always have a y-intercept.